Assalamu alaikum everyone. Welcome. I would like to start by thanking Nur Afzal sir, our respected associate professor from the Department of Computer Science and Engineering. Sir, it is a great honor to present in front of you today. I truly appreciate all the support and knowledge you share with me. Thank you for always guiding and inspire me. Now let's move on the main focus of today's presentation as you can see on the screen. The topic of our discussion is a crucial aspect of computer architecture, the third version of multiplication and division algorithms. The presentation is part of our computer architecture course. Throughout these seasons, I will walk you through the details how these algorithms function, their significance and their practical application in computer system. Let's dive in and explore in intricacies of this important topic. Then, introduction, the third version of multiplication and division algorithms in computer architecture focus on optimized arithmetic operation. These methods improve speed and accuracy by minimizing step and handling overflow issues efficiently. This presentation will cover the step-by-step process, tables, and examples to demonstrate these algorithms in action. Okay, what is the third version multiplication algorithm? The third version multiplication algorithm is an optimized approach to multiplication. It's especially useful in handling large numbers and performing complex calculation more efficiently than some irrelevant methods. We will go through each step to understand how it's work and weigh its advantages. Okay, multiplication algorithm overview. Bode's algorithms is overview. Bode's algorithm is used for multiplying signed binary numbers efficiently. It's minimize the number of addition and subtraction operation by using bit manipulation, making it faster. And key features of Bode's algorithm and supports both positive and negative numbers and reduces the number of arithmetic operation, thus increasing efficiency. Uses bit patterns to determine when to add, subtract, or shift. Then, how to works? We initialize three registers. A for accumulator is equal to 0. Q multiplier Q minus 1 previous bit is equal to 0. We then check the last two bits Q0 and Q minus 1. Based on the pattern 0 0, 0 1, 1 0 and 1 1. We either add, subtract, or perform a right shift. The process repeats for each bit in the multiplier. Then, Bode's algorithm, a step-by-step guide. Bode's algorithm is a clever way of multiplying two binary numbers, especially used for numbers with both positive number and negative number. It reduces the number of operations needed, making multiplication faster. Let's break down how it is working using a flowchart. Initialization start by setting up the initialized value accumulator 0. This is the accumulator which will store part of our result. Then q minus 1 is equal to 0. This is an extra bit that helps us decide whether to add, subtract, or do nothing. Then m is the multiplicand, the number you are multiplying with. Q is the multiplier, the number we are multiplying. Count is equal to n. This is the number of bits in the multiplier q. And then step 2, check q0 and q minus 1. Look at the two bits, the last bit of q0 and q minus 1. If q0 and q minus 1 is equal to 0 1, then add m to accumulator is equal to accumulator plus m. And then this happens because a 0 1 patterns means and there's a positive section of the multiplier. Then if q0 q minus 1 is equal to 1 0, then subtract m from accumulator to accumulator is equal to accumulator minus m. This happens because a 1 0 pattern indicate a negative section in the multiplier. Then if q0 q minus 1 is equal to 0 0 or 1 1, if working, do nothing, just go to the next step. Then step 3, arithmetic right shift. After addition or subtraction, we do not arithmetic right shift on accumulator q and q minus 1. Then this means all the bits are shifted on position to the right. The sign bit of accumulator, the leftmost bit, then remains unchanging to keep the numbers signed intact. The bit from q0 moves into the q minus 1. Then step 4, repeat until count is 0. Check is the count has reached 0. Then if count is equal to 0, the algorithm stops. Then if count greater than 0, go back to step 2 and repeat the process with the update accumulator and q minus 1. And then last one step and get the result. Then once the count reached 0, the multiplication process is complete. Then the final product is stored in accumulator and q combined. Then full explanation of Bode's algorithm multiplication. Let's break down Bode's algorithm with a details example. We are going to multiplying two numbers, multiplicand 3. This binary number is 0 0 1 1. Multiplier is equal to 6. This binary number is 0 1 1 0. Step by step explanation. 1. Initialization accumulator 0 0 0 0. And then q multiplier 0 1 1 0. Then q minus 1 previous bit is equal to 0 and multiplicand 0 0 1 1. Here a is initially set to 0. Then step 1, checking the bits and performing operation. Check the last two bits, q0 is equal to 0 and q minus 1 is equal to 0. Then operation, the bits are 0 0, so no operation is needed. Then we perform an arithmetic right shift and a q and q minus 1 together. A result after shift, a is equal to 0 0 0 0, then q is equal to 0 0 1 1, then q minus 1 is equal to 0. Okay, step 2, checking the bits and performing operation. Okay, check the last two bits, q0 is equal to 1 and q minus 1 is equal to 0. Operation, the bits are 0 1, so we add the multiplicand to a. Okay, then addition, a is equal to 0 0 0 0 plus 0 0 1 1 is equal to 0 0 1 1. After addition, perform an arithmetic right shift. Result after shift, a is equal to 0 0 0 1, then q is equal to 1 0 0 1, then q minus 1 is equal to 1. Step 3, checking the bits and performing operation. Check the last two bits, q0 is equal to 1 and q minus 1 is equal to 1. Operation, the bits are 1 1, so no operation is needed. Perform an arithmetic right shift and a q and q minus 1. Result is after shift, a is 0 0 0 0, q is equal to 1 1 0 0, then q minus 1 is equal to 1. Then step 4, checking the bits are performing operation. Check the last two bits, q0 is equal to 0 and q minus 1 is equal to 1. Then operation, and the bits are 1 0, so we subtract the multiplicand from a. Then subtraction, a is equal to 0 0 0 0 minus 0 0 1 1 is equal to 1 1 0 1, using 2's complements for subtraction. Okay, then perform the final arithmetic right shift. Final result is a is equal to 1 1 1 0, q is equal to 0 1 1 0. Then the combined value of a and q gives the final product 1 1 1 0 0 1 1 0, this binary number, which is 18 in decimal. Okay, then division algorithm. Let me explain the restoring division algorithm, which is used for binary division. This method works for both signed and unsigned numbers and helps the computer perform accurate division. First of all, key features of the restoring division algorithm. Step 1, dividend and divisor initialization. Then we start with a dividend q and a divisor m. Then an accumulator a is set to 0 initially. Then second step, shifting and subtracting. Then in each step we left shift the combined accumulator a and dividend q by 1 bit. Then after shifting we subtract the divisor m from the accumulator a. And then next step 3, checking the result. If the result is positive, we set the corresponding bit of the quotient q to 1. Then if the result is negative, we restore the previous value of the accumulator and set the corresponding bit of the quotient to 0. Then next step, repeating for each bit. This process is repeated for all the bits of the dividend. Then next, each bit is processed one by one to determine whether to subtract or restore depending on the sign and the result. That's final step, final output. After processing all bits, the quotient and remainder are obtained. The quotient is stored in Q and the final value of the accumulator A become the remainder. Okay, next, full explanation of restoring division algorithm. Now let's go through the restoring division algorithm with an example where we dividend and divisor. Okay, dividend is equal to 10, this binary number is 1010, and divisor is equal to 3, this binary number is 0011. And then step 2, step by step explanation. First of all, initialization, accumulator 000, this that is initial value is 0. Q dividend is equal to 1010, m divisor is equal to 0011. Then step 1, left shift and subtract. Okay, shift the combination of a and q to the left by 1 bit. Then after shifting, a is equal to 0001, and then q is equal to 0100. Then subtract m from a is equal to 0001 minus 0011. And there's final result 1110. This number is negative result. Since the result is negative, then set q naught is equal to 0 and restore a to this previous value. Then result after step 1, a is equal to 001, restored, and then q is equal to 0100. Then step 2, left shift and subtract. Then shift a and q to the left again. After shifting, a is equal to 0010 and then q is equal to 1000. Then subtract m from a is equal to 0010 minus 0011. This final number is 111. This number is negative result. Again the result is negative, so set q naught is equal to 0 and restore a. Step 3, left shift and subtract. Perform one more left shift on a and q. Then after shifting, a is equal to 0100, then q is equal to 000. Subtract m from a is equal to 0100 minus 0011. This final number is 0001. This number is positive result. Since the result is positive, set q naught is equal to 1. Then result after step 3, a is equal to 0001 and q is equal to 0001. Then final quotient and remainder. The value of q is the quotient 0010, decimal number is 2. The value of a is the remainder 0001. This number decimal is 1. Thank you everyone for your time and attention. This concludes my presentation on multiplication and division algorithms. If you have any question, I would be happy to answer them. Assalamu alaikum everyone.